So we're going to put it in vertex form by completing the square, right? So I'm going to look at, of course, the first two terms, and I'm going to rewrite it. So I've got x squared minus 6x plus some number, and then I've got the plus 10, right? So what goes on that line is I take this number, right? Oh, choo-choo. Did not change it into a highlighter. I take this number, the 6, and I take the negative 6, and I divide it by 2, and then I square it. So that becomes negative 3 squared, which is 9. So that's 9. And if I add 9, I have to subtract it. So this becomes x, and then whatever it is I squared, remember, x minus 3 squared plus 1. And that's how you should have written it into the chat box. And actually how you really write it, just so you know how you write a square, it would be x minus 3 to the caret key squared. So that means squared plus 1. Okay, so the caret key is shift 6. Okay, and then and the next one, I'm going to look at the two ones again, the same ones, and I'm going to rewrite it as x squared plus 16x plus some number plus 50. Beautiful. Okay, and then in order to find out what goes on that line, I'm going to take this number, which is 16. And let's go up here, I guess. So I've got 16 divided by 2 squared, which is 8 squared or 64. So I'm going to add 64 and subtract, not add. If I'm adding 64 inside the parenthesis, I'm going to subtract 64 outside the parenthesis. And then I rewrite what's inside the parenthesis as x plus 8 squared minus 14, I think. Yeah, that's it. So good job to the 3 of you who put that into the computer. Excellent job. Okay. So now we're going to start our new notes. And of course, we have some vocabulary to start with. So we're going to go over the vocabulary first. So if you want me to pause while you take pictures of the vocabulary after we fill them in, that's awesome. We can do that. But we're just going to kind of go on and talk about this. So this says we're going to talk about the properties of parabolas. So first, what is a parabola? Well, a parabola is this picture here. It's a graph of a quadratic. They're called parabolas. And they're kind of U-shaped. And they can be either upside right or upside down. Okay, and all parabolas have a vertex, an axis of symmetry. Pretty sure I spelled that right. And open either up or down. Okay. All right, any questions on that definition? We're going to define what vertex, axis of symmetry is. And pretty much open up or down is pretty self-explanatory, right? This parabola opens up, the U is going up, and this one opens down. Okay, that's the difference between opening up and down. We'll talk about what it looks like in the equation in a minute. Okay, so all parabolas have a vertex and an axis of symmetry. We're going to talk about that in a minute. So vertex, we're going to get there. The vertex is always can I slide this up? Is always the highest or the lowest point. It can't be both. It's either the highest, so it's either this point or the lowest point on my parabola. That's the vertex. So it's pretty easy to find on a parabola. It's either the highest or lowest point. Is that okay? Any questions on that definition? Okay, and then the axis of symmetry is, this one's a little longer, so it's the line through, T-H-R-O-U-G-H, through the vertex. So it goes through the vertex so that each side of the parabola, each side of the parabola is a mirror, M-I-R-R, mirror image of each other. Okay? So if I'm looking at this picture over here, I'm going to kind of involve this picture. If I'm looking at this picture, here's my vertex, right? It's the highest point on my graph. My axis of symmetry is the line through the vertex. So I just want to say it's not this line, because that doesn't make a mirror image. Each side of my parabola have a mirror image, so it's not that line. It's the one that goes this way. It's a vertical line through the vertex. So let's add that in there. The vertical, let's add this right in here and say vertical. Vertical line through the vertex, so each side of the parabola is a mirror image of each other. Okay? So if you, I can show you a few things here. So if like this point on this side, notice it's the same distance away from my mirror, right? On the other side of the axis of symmetry. And all the points are like that. So if I find this point here, it's 4 away. So on the other side of my line of symmetry, it's 4 away. So basically what that means, you guys, if I find a point on one side of my line of symmetry, I have a point on my other side because it's the same distance on the same line, same distance away from my axis of symmetry on the other side of it. So if I find one point, I've got another point, which is kind of nice when I'm graphing it because I don't have to find as many points. We're going to go there later though, okay? So let's see, the x-intercepts of the parabola can also be called zeros. Oops. Let's put that in the right spot because I didn't see that that's an or. Zeros, or roots. Okay, so if you hear, if you're looking at the directions and they ask for zeros, they're asking for the x-intercepts, or roots, they're asking for the x-intercepts. So sometimes the wording are either, they can use any of the 3 words looking for x-intercepts, either x-intercepts, zeros, or roots. They're all looking for just the x-intercepts, okay? And then the last thing here is it's possible for a parabola to have 0, 1, or 2 roots. So it all depends on where my vertex is on how many roots it's going to have, or zeros or x-intercepts, whichever you want to call them, okay? Any questions on the vocabulary? And I'll just pause it there in case you guys want to take a picture of that vocabulary, unless you have written it down. Okay, we're going to go ahead and go to the next page. We have a little bit more definitions at the top here. And we're going to talk about, now we're going to talk about vertex form. And we've kind of already talked about it when we were doing, see, look, I can't even talk. When we were converting to vertex form, right? When we were doing completing the square, we were putting it into this form, which is a times x minus k squared plus, oh my gosh, why didn't it save correctly? This should be h. X minus h squared plus k. I thought I'd fix that problem. Equals, oh, okay, oh, I know why I didn't fix that. So that's just totally thrown me off. Okay, So if you pull up the notes from Canvas, it's fixed in there, but I put this up in here before I fixed that issue. So it should be x minus h squared plus k. That's the correct form. And each one of those letters means something except for x. X is just x. It just stays there. So A tells me which way it opens. It also tells me something else, but we're not going to go there right now. We're just going to do A equals 1. All the parabolas we're going to work with is A equals 1 or negative 1. Okay? So we're going to talk about that when we get down here a little bit further. And H and K is my vertex. My vertex is HK. So if I have an equation, I can find the vertex. I do want to point out, though, notice in my equation, H is negative and K is positive. So that means when I pull it out of my equation, H, the sign changes. And here my sign stays the same. Hey, you guys. Okay. Sorry, I need to restate this last statement. They do change and stay the same, but it depends on where I'm looking at them, where I'm pulling them from. So if I'm going from the equation to the vertex, this H changes, and this K stays the same. The K always stays the same. It doesn't matter. And if I'm going from the vertex to the equation, then this H changes, and this K stays the same. So the H always changes signs, and the K always stays the same. It's always the same sign. Okay, and we'll talk, when we get some problems, when we have some examples, you'll understand that better when we start talking about it, okay? And the axis of symmetry is always x equals h. So it's always the x equals the x coordinate. Oops, coordinate. Yeah, honey.
Are these notes?
Yes. Okay. You're welcome. X coordinate of the vertex. Okay? So, and then the left and right sides of the graph are symmetric or mirror images of each other, which we talked about the axis of symmetry. And then from the vertex, well, we're going to talk about this last part in a bit. I want to show this on the graph now. So if I have my vertex, which happens to be 0, 0, so my vertex is 0, 0. Okay, can everyone see that? It's right here. It's the lowest point at 0, 0. My axis of symmetry, which way when we draw our axis of symmetry, it's always a dotted line. We're not going to do a lot of graphing, but you guys will see if you have to draw it in, draw it as a dotted line, because a solid line means that it's part of the graph. So we draw it in as a dotted line. So my axis of symmetry, AOS, and they just abbreviate it AOS so you don't have to spell it out all the time, is going to be x equals whatever the x coordinate of my vertex is. So this is my x and this is my y, so it's x equals 0. Okay? So now if I'm going to put this into my formula, the only other thing I need to know for my vertex form is what A is. It's so easy to find. And I'm going to kind of zoom in on the graph so you can see what I'm doing. I start at my vertex and I go over 1 and see how far up I go. If I go over 1 square, how far up do I go till I hit a thing? Well, if I go up 1, A is 1. If I go up 2, A is 2. If I go up a half, A is a half. Does that make sense? However far it takes me to go up to the graph is what A is. Well, it took me 1 unit. So in this case, A is 1. Okay, but just so you know, all of these parabolas we're going to do now, A is going to be equal to 1. Okay, later, maybe later tomorrow or next week, we'll do A something else. But right now, we're just going to do A equals 1 or negative 1. So you're either going to go up 1 or you're going to go down 1. So the A is going to be pretty easy for you guys. So now I'm going to write the equation of this parabola and show you how you substitute it in. It's pretty easy, right? Because I have an X, I have an A, I have an X and a Y, and I guess it could also be, since I need to rewrite this. Since our definition is HK, I'm going to actually write this as 0. Oh, that's not a 0. Wow. This would be 0, 0, right? That's what my vertex is. So I'm going to write the equation over here. So I have f of x is going to equal A, and A is 1, times x minus h. Well, h is 0 squared, plus k, which is 0. Whew. Now I want to simplify it. Do I have to have... Oh, no, that's not the question I want to ask. What is x minus 0 equal? Does anyone know what x minus 0 equals? Anybody? X minus 0. What is x minus 0? Well, x minus 0 is 0, just so you guys know. And I don't have to write the 1, so this just becomes x squared. So the equation for this parabola is f of x equals x squared. And that's it, done. So I just substitute it in. And if there's a 0, I can make the zeros go away. Okay, zeros don't have to be there. But if there's numbers, I would leave it there. And we're going to show you that in just a minute, too. And then from the vertex, if A is 1 or negative 1, the next few points can be found by, how do I want to put this? So what I did to get to that point, I moved, do I want to say to the right? Yeah, right 1, right, G-H-T, up 1. And then the second one would be right 2, up 4. I'm just going to square this number. And then right 3, up 9. And if I went to the right 4, how far up would I go? Can someone tell me? What would the next number be following the pattern? So if I was at this, I could go left too, by the way. It doesn't have to be right. I could be left. If I went over 4, 1, 2, 3, 4, how far up am I going to go to get to my graph? How far up do I have to go? So basically, this is my x value. This is my y value. And I'm putting it into x squared. So how far up would I go? Can anyone tell me? Is anyone listening? Hello? Okay, so 1 squared is 1. 2 squared is 4. 3 squared is? So what's 4 squared? There you go. That's it. So if I go over that many, I'm going to go up the squared amount. So if I go over 2, I'm going to go up the squared amount. 2 squared is 4. If I go over 5, which, by the way, would never be on a graph. You would never graph that much. If I go over 5, I would go up 25. Usually the most you go over is 4 to graph a point, okay? But that's how you build a parabola if we're going to graph them. It's pretty easy to build it. You don't even have to plug points into a graph if you know where the vertex is. You can just do this step movement. Okay? Catlin, do you need a second more to write this down?
Yes.
Okay, I'm going to pause. All right, so next what we're going to do is we're going to look at an equation first. And from that equation, we're going to identify the vertical, the axis of symmetry, and which direction the parabola is going to open. Is it going to go open up or down? Okay? So I'm going to look at this, and I'm going to rewrite the vertex form over here. So we've got f of x equals a times x minus h squared plus k. So the different parts are the vertex is hk, okay? The axis of symmetry, or AOS, is x equals h. And then the direction it opens up if A is positive, and it opens down if A is negative. Oh, let's write that backwards. Let's write this as a positive A and negative A. If I have a positive A, it opens down if I have a negative A. Okay? So those are what I'm going to use, and basically that's what I need for anything. Whether I'm graphing it, I pull that information off the graph, or I pull it outside of the equation. I'm going to use the same information no matter what. Okay? So if I'm in number 1, I want to look for h and k. So here's h, and here's k. All right? So I know this. I need it to be a positive 4. In here, so this is the tricky part with finding the vertex. In my equation, this is negative. Is this negative here?
No,
That's a positive, right? So how do I get a negative to become a positive?
you flip.
What do you mean flip?
Flip the minus and that. I don't know.
Let me ask a different question. Let me think of how to word this question. If it's supposed to be a negative, what do I multiply it by to get a positive? If this is a negative, right? What do I multiply a negative by to get a positive?
I don't know.
A negative times a what equals a positive?
Negative.
Negative, yeah, good. So that means my vertex has to be, my h has to be negative 4, because when I plug it into this equation, I'm running out of room to write, but I'll write down here. Because if I plug it into my equation here, right, a times, which is 1, by the way, because there's a 1 out here in front, right? A is 1. I have x minus, and then I put a negative 4 in there. What's minus a minus become? Positive, hence my positive up here in my equation. Does that make sense? That's why I remember when I said it changed signs. So if it's inside the parenthesis, it's going to change signs. So if it's a positive 4 in here, when I pull it out to my vertex, it becomes a negative. If it was a negative inside that parenthesis, when I pull it out, it becomes a positive. So the signs change. When I pull it out of the equation for the vertex, that sign that's inside the parenthesis changes. Okay? And then the sign on the outside just stays the same. So my vertex is negative 4, negative 3. And my axis of symmetry is going to be x equals -4. Remember, it goes through the x coordinate of my vertex. That's the easy one. Once I have my vertex, I know what my axis of symmetry is. And the last thing I need to know is which way this parabola is going to open. So which way does this open? Is A positive or negative? A is the number in front of the parenthesis. Is it positive or negative?
Negative. No, it's positive.
Good, thank you. Yeah, this number out here, right? Let me highlight that so everyone can see it. This number right here is positive. So therefore it opens, up. And that's it. So let's try it again over here for number 2. We're going to answer the same questions. I'm going to look at A, which is here. That was an eraser. Okay, I'm going to look here at A. I'm going to look at H, and I'm going to look at K. Okay, those are the things I want to look at. So my vertex is going to be this sign changes. This one stays the same. So this changes. Stays the same. So my vertex is going to be 1, -2. And my AOS, axis of symmetry, is x equals 1. And then it's going to open. Well, A is negative this time. See, there's a negative out here. So it's going to open down. Okay, I want you guys to try this. On the first one, let's see, vertex. Oh, hate it when I do that. So I'm going to look at this one and then notice, there's no parenthesis on that one that makes it a little harder, and then this one. So remember the H is inside the parenthesis. If there's no parenthesis, what number would that be? And both of you guys who filled that in got that correct. Very good. It would be 0. If there's nothing there, if there's nothing being added to the x, that's just 0. And then 6 is being added outside of the square. And then my axis of symmetry is x equals 0. And it opens, because my x squared is negative, and it's going to open down. Okay? And then on the last one, I'm going to look at this one. Eraser. This one, and that one. So my vertex is going to be 5, -4. My axis of symmetry is going to be x equals 5. And it's going to open up. Yep. Nice. Okay. Are we okay with that? Not, it's okay. Yeah. So, yeah, okay. Well, we're going to go pull it out of a graph now. Okay? And pulling it off a graph is what your homework is going to be. So, because that's the most important thing. Okay. And we'll go over this again tomorrow somehow. I'll figure it out. As I think about it. Okay. So again, we're going to use the graph to find the vertex, the axis of symmetry, and we're going to write an equation for it. Okay? So I'm going to write the equation out here. And remember, I already said all the A's are either 1 or -1, right? So, okay. So I need to find my vertex. And the vertex is the highest or lowest point, so it's this point right here. And remember, when we read a point off a graph, I'm going to zoom in on that, okay? We go this way first, so we read this way first, our x values first. So I'm going to go over from my 0, 0, and I went over to -1. And then I went down 5. So that would be negative 5. So there's my vertex, negative 1, negative 5. Everyone okay with that? And then my axis of symmetry, of course, is just x equals negative 1. Make sure if you're not understanding, you're asking questions. And then my equation, I'm just going to substitute in. So this is going to be h. By definition, this is h and this is k. So I'm going to substitute it into my equation. And I've already told you, right, that a either equals 1 or negative 1. And how do I know if it's 1 or negative 1? Well, if it opens up, a equals 1. And if it opens down, a equals negative 1, okay? So my graph is opening up, so a is going to be equal to 1. So I'm going to say f of x equals 1 times x minus h, which is a negative 1 squared minus 5. Now I need to make it simpler. Yeah, that's right. F of x is going to, I don't have to write the 1 again, so you can write it. It won't be wrong, but most of the time you don't see the 1 on the outside. And x plus 1, because minus a minus is a plus, minus 5. Done. Questions? Oh my goodness. They are so loud out there. They're painting all the metal in the school. Okay, where's that vertex at? Can everyone write the vertex in the chat? Tell me where that point is, please. I haven't put a dot on it for you. Put it in the chat box. Nice, Alex. Come on, everybody, put a... What the heck? Crap on a cracker. Okay. Okay, just put a question in the chat box. Please, everyone answer it now. Because I'm taking roll again, so everyone needs to answer it.
Which one?
I put it in the chat box. So out of the 6 of you who answered, how come only one person can tell me where the vertex of this graph is?
I for some reason thought you were asking for what 8 times 7 was. And
It was. I did. Alex Walker, I did. But I've been sitting here waiting for people to tell me what the vertex of the graph is, and no one answered me except for one person. So I put a different question in the chat box to see who was actually here in class, instead of just have their cameras on and not paying attention. And how come you can't answer my questions? It's not a hard question. Where's the point on the graph?
The one from the left side or right side?
The one that's showing, the yellow one. Oh, sorry, you could see both of them up there. The yellow one. We already did the purple one.
Is it for -6? Or right, we're gonna go down -6? -6?
Yes, it is. Hey, Alex, that's great, by the way. Nice job on answering all the questions. So my vertex is 4, -6. My axis of symmetry is x equals 4. And then because it's opening up, a is 1. So I have f of x is going to equal 1 times x minus 4 squared minus 6 by substituting it into my equation, which is right over there. Right there. So to simplify it, I get f of x equals x minus 4 squared minus 6. Okay, now it's your guys' turn. Write the equation. Okay, so my vertex is here. It's -2, -3. My axis symmetry is just x equals -2. And a is 1 because it's opening up. So f of x is going to equal 1 times x minus a -2 squared minus 3. And if I simplify that, it's f of x equals x plus 2 squared subtract 3. And then the second one, or number B, let's see, where's my vertex at? It looks like it's at -1, +1. So the axis of symmetry is x equals -1, and it's opening up again. So a is 1. So f of x equals 1 times x minus a -1 squared plus 1. So if I simplify that, I get x plus, that is not an x. Let's try that again. X plus 1 squared plus 1. Okay? So now we're going to go, we're going to stop here because this is the end of the notes. And I want to show you basically what your exam, I'm going to not stop quite yet. Basically what your assignment is they're going to give you a graph and you have to come up with the equation. So really what I look at when I'm doing this is I'm going to look at the vertex. I'm going to find the vertex, right? Notice My vertex was negative 2, 3. What did my graph, my equation ended up being positive 2, negative 3. Do you see that? Positive 2, negative 3. Change here. Change. Same. Okay. Here my vertex was negative 1, 1. My equation was positive 1, positive 1. Change. Stay the same. So let's go ahead and